So today we'll be talking about networking and network security. Now, as cybersecurity personnel, depending, no matter the niche you actually planning to go into, networking is very, very important as cybersecurity. Even as an hacker, you have to be very conversant with how networks or how IP addresses communicate. It is very, very important. Cybersecurity person that tells you he or she is into cybersecurity and doesn't have any idea about networking, then I don't know what to say about that. So today we'll be talking about networking and network security. So first, what is networking? Now, networking is the practice of connecting two or more computers, devices, or systems together to share resources, exchange information, and communicate efficiently. Now, network is a group of interconnected devices that share resources and data. So what networking actually means? Networking is just the practice of connecting two or more computers. Now, for instance, now in your houses now, if you on your device, maybe on your mobile device, if you turn on your hotspots and you connect two or more devices, probably your friend join your device or your laptop is connected to your hotspots. Now you have created a network. That is what it means by a net. That's what they mean by a network. So when your devices are interconnected, for instance, there's something we call IoT of things. I think I've talked about of things before, whereby you have smart refrigerators, smart doors, smart printers, smart cameras. When you connect all those things together, you've created a network. So that is what a network is all about. Now, why network matters? Now, to enable communication, collaboration, resource sharing, remote access, and business continuity. So network matters so that you can enable communication. That is one of the reasons why network actually matters. Now we have types of network. We have LAN, which is the local area network. Now this is a network that is created for office, school, or home. For instance, now probably you have a router in your house and all your devices are connected to your router. That is local area network because it is just within your home or your office. Then we have wide area network. This has to do with large geographical coverage, that is the internet. So the moment you are communicating from your house, probably on WhatsApp, you send message to somebody that is outside your vicinity or outside your compound, then that is you are using the internet, which is the wide area network, to communicate. Then we also have the MAN, which is the metropolitan area network. This covers a city or campus. So they can set up a MAN network in a campus area or university, whereby it is only within the university. Then we also have WLAN, which is wireless LAN, that is uses Wi-Fi instead of cables, that is wireless connections or wireless network. Then we have VPN, which is virtual private network. So what VPN is all about is that it creates a secure tunnel over public networks. Instead of you to use your own IP address to communicate, it routes your traffic through another IP address to create a secure tunnel for your network. Then we have common network terminologies. First one, we have bandwidth. Now, this has to do with the maximum amount of data that can be transmitted over a network connection in a given time, in megabytes or gigabytes. So bandwidth has to do with the amount of data that you can transfer at a particular time over the network is what we call bandwidth. Then we have latency. The time it takes for data to travel from the source to the destination is measured in milliseconds. So when you have a network delay, it is known as what? Latency. Then we have throughput. Now, the actual amount of data successfully transmitted over the net often less than bandwidth due to delays, errors, or congestion is known as what? Throughput. I think that's self-explanatory. Then we have packets. Now, a small unit of data transmitted over a network. Packets include headers, control info, and payload, which is your data. So I think I've told you once before that the way you communicate over the internet, the way your messages move over the internet, it's actually through something we call packets. Now, next one, we have subnets. Now, this is a subdivision of IP, which is Internet Protocol Network, created to improve management and security, defined using a subnet. Example, 192.168.1.0/24. Now, this is a subnet. Subnet just actually means how many networks are actually on this particular, how many devices can be connected to this particular network. So you create a subnet to be able to segment your networks. Now this /24, we will get to that later, is something called, we call it CIDR, that is a subnet mask for you to determine, okay, this is the number of devices that are actually on this network. Then next one, we have NAT, which is the network address translation, a method of mapping private IP address to public IP address before sending traffic to the internet. Now, one thing about NAT is that as your device, your device has both a private IP and a public IP. Now, what you use to communicate with the internet is your public IP. Now, what the NAT does is that it helps you to translate your private IP to be able to communicate over your public IP. For instance, now if you turn on hotspot for your friends, let's assume you are the one with the hotspot and you have about 4 friends that are connected to your hotspot. Now, all those your friends, your device will actually administer a private IP to each of their devices. Now, the person's IP that they're using to communicate over the internet, it is your own IP that is having the public IP address at that moment. So everybody is actually using your public IP to communicate over the internet. So the way their private IP translates to using your public IP is known as this NAT, which is a network address translation. Then we have the VPN. I think I explained that is a secure tunnel to protect your IP address. Then we have firewall. Now, firewall is used to filter packets depending on the rules that you actually give to your firewall. So it helps you to filter traffic. Any traffic you don't want, you can set inbound rules for traffic that are coming into your system, and you can also set outbound rules for traffic that are going outside your network. So we have IDS and IPS. So this IDS is intrusion detection system, while IPS is intrusion prevention system. Now for IDSs, we have 2 types. We have the network-based and we have the host-based. Now the host-based IDS, because what IDS does is that it monitors alerts on suspicious activities. That is, the IDS detects alerts based on your rules also, while IPS prevents malicious traffic coming to your network. So I said we have the 2 types. We have the host-based. The host-based, you actually install it on individual computers or individual devices, while the network-based is just once because it has to do with network. So anybody that is connected to that network will fall under the guardians of the IDS and the IPS. Of the IDS and IPS, we have SNOT. Probably if time permits us, I would show you what that means. Then we also have a proxy server. Now, acts as intermediary between a client and the internet, can be used for caching, anonymity, and filtering traffic. So proxy servers can also be used to filter your traffic. Then we have load balancer. Now, this distributes network traffic across multiple servers to improve performance and availability. Now, load balancing is actually a means of trying to make your network have the speed it deserves. So you can use a to separate the work your network is doing. For instance, most times it's used on web servers because for websites now, if they use a load balancer, so the the um they can separate what your website can actually handle. For instance, when it comes to your front end, which is your graphics, they can use a different server to handle that. When it comes to you getting response from your website or from your web server, they can use a different server to handle that. So that's what we call load balancer. Then we have a DHCP, which is Dynamic Host Configuration Protocol. Automatically assigns IP addresses and configurations to devices on a network. Now, this DHCP is a protocol that has been configured for most devices. Now, if you have a router in your house or you have let's assume you have a pocket MiFi. Now, if you want to connect to your MiFi, I don't know if you've noticed it, probably if you turn on Wi-Fi on your phone and you want to connect to your friend's hotspot, you realize it is telling you that it is trying to administer IP address to your device. Now, the protocol that is administering that IP address to your device is known as a DHCP protocol. Assigns IP addresses from a pool of IP address to your device to enable it to communicate within or to see it as part of that network. Now we have DNS, which is domain name system. Now this translates human readable domain names, example google.com, into IP address. Now, one thing about DNS is that all the websites you actually visit communicate through what we call IP addresses and with other factors too. But one of the main thing is IP addresses. Now, because as human beings, we cannot actually remember IP addresses. For instance, now imagine going to your browser, instead of you typing google.com, you have to remember, okay, what is Google's IP? 192.168.this.this. It would actually be difficult for you to remember websites based on their IP addresses. So what DNS does is that it has been configured to your browsers, whereby once you type in google.com, automatically in the background, that google.com is translated into the IP address of google.com, because your own IP address will now go and look for the IP address of google.com. So what makes that possible is the DNS, which is the domain name system. So it helps to translate your domain name, which is the website you are visiting, into an IP address that you do not see. Then we have SID. This has to do with the name of the Wi-Fi network you are using. If you are using an hotspot now and you set a name to a particular name, that particular name you set it to is known as your SSID, which is your service set identifier. Then we have ping. Now, a diagnostic command that uses ICMP to test connectivity between devices. So when you ping a device, it is for you to check whether the device is actually active. That is what ping is used for. Then DOS and DDoS, we have denial of service and distributed denial of service. I think I've explained these ones. So when you visit a website, there's an amount of traffic that a website can actually, or amount of requests a website can actually accept at once. We call it SYN request, which is SYN request. Now, most times when you visit a website, you are making a request for you to be able to visit that website. So the first thing that happens is that your own IP address, for instance, now if you type google.com, what happens in the backend is that your IP address goes to look for the IP address of google.com. Now, the process of it looking for that IP address is called a SYN request. That is, it sends a SYN request to the IP address of Google. Hey, Google, I want to connect. That is what your IP address says. Now, Google IP will now respond to your IP. Okay, you said you want to connect. I am here so that we can connect. that is called a SYN and ACK. We call it SYN and acknowledgement. Now, when your own IP now accepts to connect to Google's IP address, we call it an acknowledgement. So that's what we network, we call it the three-way handshake, whereby first you send a SYN request, then you get the SYN and acknowledgement before you now acknowledge. So it is after you acknowledge, that is when you actually can communicate between the website and you. That is when the connection has been made. So what am I explaining about this DDoS is that when you make a request to a website, there is an amount of requests that the website can actually undo at once. I don't know, some of you in school, maybe they open your portal for a particular registration. It's either the website is slow or it's telling you that you cannot actually reach the website. It could be because the number of people that are visiting that website are more than the number of people that the website can actually handle, or we say it's more than the number of SYN requests that the website can handle. So that's enormous request to that website is known as a DOS attack. So now the DOS attack happens in the sense that a single person can actually make their devices or tools whereby a single person can use to make that request to that website. Imagine sending more than 1 million requests in a second to a particular website. If the website is not well secured or cannot handle that kind of request, it will either crash or it will be slow. Now, the difference between denial of service and distributed is that the denial of service is a single person that is sending that enormous request, but distributed denial, different devices, an hacker could actually employ your device, probably through phishing method or through any method, to assist it in sending a SYN request. So imagine me sending 1 million requests and like 1,000 other devices sending 1 million requests per second to a particular website. That is what we say it is a distributed denial of service. Now, one of the ways to actually mitigate against that, for some people, when you visit a website, you see Cloudflare. Now, Cloudflare is one of the ways to mitigate against DOS attacks, so that they ensure that it is not a robot or you are not sending too many requests at the same time. So we have common network protocols. We have HTTP, we have HTTPS. Now, these are web communications. That is, this is how you communicate over the internet. So the protocol it uses to communicate over the internet is known as HTTP. Now, the difference between HTTP and HTTPS is the fact that HTTPS has S, which is a secure network, which uses TLS and SSL to actually encrypt the data that is being communicated between the website and you. Then we have DNS. I explained that it converts domain names to addresses. Then we have FTP, which is file transfer protocol, or SFTP, which is secure file transfer protocol. Now, most times FTPs are used by probably sites where you download movies. Most of those sites where you download movies from uses a protocol called FTP because it just has to do with file transfers. Then we have SMTP, IMAP, and POP3. These are the protocols your emails uses. Whenever you send an email address, these are the protocols it uses for you to send and receive email address. Then we talk about DHCP, then ICMP, Internet Control Messaging Protocol. That's the full meaning. So what ICMP does is when you ping a device, the response you get is known as an ICMP request for you to know if the device actually responds or if the device is not active. Then the next one, we have basic network devices. The first one, we have a router. Now, some of you might have seen a router before. This is how a router looks like. So we have a switch. Now, a switch connects devices within a LAN area network. So this is an example of a switch. So they connect different devices to a switch. Now we also have a hub. It's also like a switch, but the difference is that a switch is actually smarter than a hub. Most organizations now do not use hub, they make use of switches, because the reason why hub is not that secure is that when you connect devices to a hub, now if device number one sends message to a particular device, now a hub doesn't know the difference when it is sending to a particular PC. Hub will communicate. For instance, now if you are sending I within a network, a hub will communicate all your messages to all the devices on that network. You understand? But a switch, it will only direct your message to the particular device that you are directing your message to. That's the difference between a switch and a hub. So a switch is smarter than a hub. That's why most organizations make use of switches. Then we have access points. Now, this provides wireless connectivity. You must have seen it probably in universities, whereby you see a device attached to your hostel. So that is what we call an access point, because it provides wireless connectivity. Then we have a firewall. Now, a firewall filters traffic, just like I explained before. A firewall could be a hardware like this, and you also be a software, because all PCs actually come with firewalls installed. So the next one we have, so this is how a network, this is like a network topology, how a network is being organized in an organization. So from the internet, we have a firewall, then your firewall is connected to your router, and your router is connected to a switch with a firewall again in between. So your switch is connected to your authentication server, probably, or your database server, or any server you have in your organization that you need to get access from. Then if you look at this side, a switch is connected to the router. Now the switch is now connected to different devices. So we have a smartphone here too connected, and we also have a laptop using wireless connectivity. So this is a simple topology of a network in an organization. So the next one we have here is IP addressing. Now, what is an IP address? An IP address is known as Internet Protocol Address. Now, this is a unique number assigned to every device on a network. Now, every device is, so far you have a network running through your device, or you have a SIM card in your device, you are actually being assigned an IP address, because you need an IP address to communicate over the internet. Now, it identifies, that is, your computer, your phone, or printers. Printers fall under examples of IoT of things like smart devices. They all make use of IP address. All those smart doors, smart microwaves, smart refrigerators, all those smart devices are called IoT of things. They all make use of IP addresses to communicate. That's why sometimes when you enter a bank, you realize that almost everybody in the bank can print from a particular printer, and you realize that there are not much wires. And if 10 people can print for this printer, that means you're supposed to be seeing like 10 wires going into that printer. But some of those printers are actually smart printers and uses IP addresses to communicate, because they've been configured to be part of the network. That is why it is easy for them to communicate with that printer. Now, we have different types of IP addresses. We have the IPv4 and we have the IPv6. Now, Internet Protocol version 4 is an older and still widely used version. It uses 32 bits. Now, it is written as 4 decimal numbers separated by dots. So, example, we have 192.168.1.1. This is an IPv4 address. Now, the total possible addresses that an IPv4 address can actually have is about 4.3 billion address. Now, if you look at the population of the world now, we are far beyond this. That is why they are trying to move to IPv6, which has about almost unlimited IP addresses. Now, an IPv6 IP address is, you can know IPv6 IP address. It has 128 bits. You can see it. It is written in hexadecimal, separated by columns. So this is an example of an IPv6 address. So most of our devices have both IPv4 and IPv6 addresses. They are just trying to move to the IPv6 address because of the limitation of the IPv4 address. The next thing, we have public IPs. We have public versus private IP address. Public IP address is unique and routable on the internet, assigned by your internet service provider, ISPs, for instance, MTN, Airtel, Glo, as in Nigeria. That is what they mean by your ISP. Now, example of a public IP address, we have 41.190.90.15. That is an example of a public IP. Now, you need a public IP to communicate over the internet, not a private IP. Now, we have a private IP. This is used within your local network, that is your home, offices, not routable on the internet. For instance, for most of you that make use of Xender, if you want to connect your Xender to another device, you notice it will tell you that it is allocating IP or searching for IP address. Now, when it connects, you realize that it uses hotspot and Wi-Fi. That is, your devices is trying to tell you that your devices must be on the same network. So when device A, which is the one that is sending, assigns IP to device B, it shows that, there was a time Xender could actually send to about 3 devices at once. Now, the way it does that is that it assigns IP to those other devices and ensure that they are on the same network and on the subnet. When we do the calculation, you understand what a subnet is, and they are the same subnet. So the moment you're on the same subnet, you can actually transfer files and you can communicate. That is the essence of a private IP. That is for you to be able to communicate within your home and your office. But the moment your communication is going outside your network, that is probably you're sending a WhatsApp message, you are doing anything over the internet, then you are now using a public IP address to communicate. Examples of a private IP ranges from 10.00.0.0 to 10.255, like that. Then we have 172.1, so like that. Then IP addresses, we have IPv4. So we have the class A IP address, which is 1.0.0.0 all the way to 126.0.0. That can actually take about 16 million hosts. Then we have class B IPs. Then we have class C. We have the class D. Now, this class D and this class E, they are not publicly used IPs because, for instance, this multicast means for you to be able to communicate with different, like a group communication. That is what they use this class D IP address for. Then the class E is mostly for experiments. So this class D and class E are not publicly used. But for the class A to class C, yeah, they are publicly used. Now, inside this class A, we have both the private and the public. Then inside the class B, we have both private and public. Now, we have modern networks mostly use CIDR, which is classless interdomain routing. By the time we start the practical, I will explain that to you. Then we have, now if you notice something, you will realize that 126.0.0, it jumped 127. You cannot see 127 around here. You're only seeing all the way to 128. But if you look at the class B to class C, 192, you can see 191, you can see 192. But from 126, you cannot see 128. Now, the reason is because of what we call a loopback address. Now, the 127.0.0.1 all the way to 127.0.0.255.255. Now, if you look at it here, all the way to 127.255.255 are actually reserved for what we call localhost or a loopback address. Now, what is called a loopback address? Now, this is a communication that does not leave your device. So what it's mostly used for is used for testing servers locally. For instance, now if you have a server that you want to test, if you use of a local a local host or 127 IP address, you are trying to tell it that I want to keep communicating with my device. So it's as if you are communicating with your device. Anything, any information you are sending is sending back to your device. It is not going outside your device. That is what the 127 IP is all about. Now, our time is fast spent. We still have practicals to work on. So we have the MAC addresses. Now, MAC address is hardware identifier permanently assigned to a network interface card. That is, all devices have what we call a MAC address. MAC address is an identifier to show that this is your device. Most times it comes from your manufacturer. It comes from your manufacturer. Now, there's a particular part of this MAC address that determines the manufacturer of your PC. So the three things that actually helps you to communicate over the internet is called IP address, your MAC address, and a port number. By the time you get to port, you understand what port does. So it is written in hexadecimal. Hexadecimal just means combination of letters and numbers. That is what hexadecimal means. So use at the data link layer in the OSI model. Ensure devices are uniquely identified on a local network. So that is how you are also able to know that, okay, this is the particular device I'm actually sending my message to. It is because of your IP or MAC address and also your port, also the port number. Now we have common network commands. So we have ping. This is for you to actually check if a network is active. We would be using that later. We also have IP config or IF config. Now, if you're using Windows, it is IP config. If you're using Linux or Mac OS, it is if config. Now, this is for you to check your IP addresses and your subnet mask on your PC. Then we also have the NS lookup. We also have the traceat, which is for you to show the path the packets take before it reach its destination. Because I know I told you that packets are your means of communicating over the internet. That is the way for instance now, the way what they call it works. If you send a message to somebody, you normally if you give message to someone, probably you hand over your message to what they call it. But you understand what I'm trying to say when you send message to someone. Now in the network, message that you're sending to someone goes is known as packets. When we do something like that, you'll be able to use a tool that you can use to actually monitor packets. And the other command we have is ns lookup. Now this is for you to check. I think somebody asked me this one day that if you want to check the IP address of a domain system or a domain name, maybe IP address of Google, IP address of anything, this is how you actually check it. You can use ns lookup or use dig. So let's go and do some practicals. So we want to talk about how we actually subnet IP addresses. So the first thing I'll be starting with, let's start with this private IP. Let's say 192.168.1.1. Now this is a private IP which is in 4 octets, which is actually separated by dots. Now there's something we call, to easily calculate this, there's something we call BCD numbers. So we have 128, 64, 32, 16, 8, 4, 2, and 1. So this is 1, 2, 3, 4, 5, 6, 7, 8. So these are the BCD numbers. Now, how do these numbers work? Now, you realize that your computers only communicate in ones and zeros. Now, these IP addresses are in bits. Now, each octet has 8 bits. Now, for you to actually calculate this, what we do is we will make use of these BCD numbers. Now, if you would join me in the calculation, now let's look for, now we want to check for this 192. Now, for us to get 192, try and see the numbers that you can add together here without repeating any number that will give you 192. If you try that, I think it will be giving you let's see, giving you 128 plus 64. Now 128 plus 64 is going to give us 192, which means for, let me write it here. Just copy this. Which means for this 192, we'll be having, we only made use of, if you try it on your side, you only make use of 128. Now 128, because it is part of the numbers you made use of, you represent that with 1. You make use of 64, so you represent that with 1. Now we did not make use of this one, so we represent it with 0. Now if you now check what we have here, we have 1 1, then 6 zeros. That is the binary for 192. If we do the same thing for 168, which numbers can we add together without repeating any number? So I think if we try it, we have 128 plus 32 plus 8. So we have 128 plus 32 plus 8. That will give us 168. So for 168, we have 128, right? Plus 32, we did not use 64, so that will be 0 plus 32. We did not use 16, so we use 8. So that means for 168, our binary is 101010000. That is for that. Then for this one, we realize that the only numbers we will make use of for 1 will be 0, 0, then 1. So that means for 1, we have 7 zeros. This is complete. We have 7 zeros and 1. So the same thing for this. We have 7 zeros and 1. That is how we are able to get this IP address. So now let's calculate a subnet mask. Now a subnet mask, most subnet masks you see something like 255.255. Something like 255.255.255.0. So let me show you where most times I will see this. Let me show you something. So on my Windows now, if I use ipconfig, now you can see the subnet mask here, right? 255.255.255.0. That is a subnet mask. It's to show you the network or how many devices that this network is actually on. So let's calculate that. Now, if you calculate this using the same BCD numbers, you discover that when you add up everything, you get 255. You could try it on your end. So if you add everything, that will give us 1. That means we made use of all the numbers. So that will give us 1 That'll give us 8 ones. Hope is complete. So that'll give us 8 ones. So that means this one too will be 8 ones. This one too will be 8 ones. And this will be 0, 0. So now our subnet mask now, the binary is 8 ones, 8 ones, and 8 ones. Now, if you add this or if you multiply this, you have 8 here, you have 8 here, you have 8 here. 8 times 8, 8 times 3 would actually give us 24. That means this 24 is now our CIDR notation, just like we mentioned the other time. So this will be our CIDR notation. So which means this particular network that we are working on is on a network address of 192.168.1.1/24. So that means this particular subnet for this network is 255.255.0. That is how they were able to calculate this CIDR notation. So that's how they were able to calculate this CIDR notation. So now let's do. Time is really fast spent. So you guys might have to give me extra time so that I would be able to complete the practicals we have for today. So now let's create a real network and let us segment that particular network. So now we want to work on a network address of 192.168.1.0. Now, for us to actually amount of devices this network can actually take. Now you will look at this, this is our subnet max 255.255.0. Now, when we calculated the binary, we discovered that we had some zeros left, right? So how many zeros do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. Now, if I say 2 raised to the power of 8, what will I get? I will get 256. Now, if I get 256, this 256 means now you minus 2. Now, to minus 2, you get 254. Now, what this means is that on this particular network that has this, I can have 254 devices. Now, why do we minus 2 from this? We minus 2 because the first one is left out for your network address. So let's say this is 0. So this will be 0. So now this is 0. Now your network address is going to be 192.168.1.0/24. This is going to be our network address. Now, the next thing they also leave out what we call the broadcast address. Now, your broadcast address is going to be the last IP address on that network. The last IP address on that network will be 192.168.255. Now, these are the two addresses that are left out. That means the number of networks you can have is now going to be 192.168.1.1 all the way to 168.1.254. So if you calculate this now, you discover that you have 254 devices on this network. So what is our network address? 192.168.1.0/24. Now in this network address, we can have this network. Now if you want to have another network address, we have 192.168.2.0. Now, this simple 2 that you're looking at that is coming before the 0 is no longer, it's as if you have a jump of 254. Now, let me explain that. For instance, now, if I go this now and I go to 255, the next thing I change to 256. Now, if I want to change to 257, instead of me to go to 257, it is impossible for me to go to 257 because of the networks we have. Now, for me to go to 257, the one that I'm adding to my 256 will not translate to me having a 2. Yeah, that is the jump of the 257 that I am supposed to have. So that is what happened. That is what happened here. Instead of me to have 19.168. So that is what is happening.
Mr. Anthony, excuse me. I think some people want to ask questions that are confused.
I'm quite.
You will see as your questions. Let's just continue first.
Okay.
Don't worry. Just stay with your questions. You will still ask. So now this is a network address for this. So that means I have 192.168.2.1 all the way to 192.168.2.255. The same thing goes again. I can see have 192. I can see have another network. I can see have another network address here, but instead of it to be 2, it will now be 3. So this is under a subnet max of 255.255.0. Now let's assume we want to have another subnet max. We want to segment our network in a different way. So let's say this one now we added 3 ones here. So let's say we add 3 ones here. So that means our ones now, we have 24 before, plus this one, that means we have 27, right? So that means we want to create a network of a CIDR notation of 27. How do we know it is 27? We have 8 raised to the power of 3 now, which is 24 plus 3 would actually give us 27. So that means we want to create a network address that will have 192.168.0/27. Now, how do we calculate that? Now, let's go back to, if we go back to our BCD numbers here. So now, we have 1, 1, 1, then 6 zeros. So let's say we have 1, 1, 1, and 6 zeros. Okay. So if you add this together now, we have 1, 1, 1. If you add this together now, somebody can add this for me. 128.64.32. Please add it for me. What do you have? 128.64.32. What do you have? Anyone?
224.
224. Okay, thank you. So that means this subnet max now has been changed to 224. Now, for us to know the number of networks we can actually have on this particular device, we will use our zeros left. The zeros we have left is 1, 2, 3, 4, 5. Now, 2 to the power of 5 will give us what? 2 to the power of 5 will give us what? Anyone?
32, right?
32, okay. So 2 to the power of 5 will give us 32, which means we can actually have, now, we will do -2 for us to have our network address and our broadcast address, which means we can actually have 30 devices. This will give us 30, right? Which means we can actually have 30 devices on that network. Now, our network address will now be 192.168.1.0/27. We are no longer using a subnet mask of /24, which means our broadcast address will be the last IP address on this device. Now, the last IP address is going to be 192.168.1.31. .1.31. So our IP address here now is 192.168.1.0/27. Then we have all the way to 192.168.1.31. Those are what we can assign to a device. The same thing goes here. Stop at 31/27 network /27 network. So what we'll do is let us take a few questions. Now, please mute your mic. Now, I would like to plead on something. Who is that? Please mute your mic. Who is that? Now, I would like to plead on something. Please, I might be taking much of your time because we still have some practicals to still work on. We still need to use the Packet Tracer to show you some things. So please, but let me just get some few questions so we don't. But the thing is, when we enter the Packet Tracer, you would actually understand the calculation better. But if you feel you want to ask your question now, no problem. Let me take 1 or 2 people so we can just continue and round up. So who are the people raising their hands?
Yeah, sir. Good evening, sir.
Good evening.
The calculation. Can I see your screen? I can't see your screen at all.
Okay. All right.
Yeah, I'm having issue. I don't really understand. Starting from that.
From where?
8 raised to power. 8 times 3. That give us 24. I think it's a little bit. No, not there. Okay, I think you've cleared up the calculation already.
Now,
the
network, this is a private IP. So I think someone actually taught you about difference between private and public IPs, right?
Yes.
So this is a private IP. Now I want to generate my own. I want us to calculate how they actually generate CIDR notations and to actually know how many devices are on that network. These are also some of the ways hackers actually know, okay, when they see your IP, your private IP, they are able to know how many devices can be on that network, especially when they see your subnet mask. You understand? So we are trying to calculate how you can know how many devices. Okay, when you see an IP address with a / a particular number, how do you know how many devices are actually on that IP address?
Okay.
So I'm using this private IP, which is 192.168.1.1.
Yes.
Yeah. So we are using these BCD numbers to make us easily calculate our binary numbers. Do you understand? So now I told you that to calculate this 192 now, we just need to add these two together, right? That means we did not make use
plus
64. That means we did not make use of these ones. So since we did not make use of these ones, we'll change these ones to all zeros. You understand? That is what we have here because we only made use of 128.64 plus 64. Same thing goes here. For our 168, we only made use of 128, 32, and 8.
Yes.
and 8 to get this 168. That means we would change everything to 1. The ones we made use of, we change them to 1. Then one would not make use of,
And the
we
rest
change them to
zero.
zeros. That is how we're able
Right.
to get this. Now, same thing goes for 1. We know that 0, 0, 0, 0 plus 1. That is how we were able to get 1, right? Then for this, it is 0. Let me change this to 0 also. So for this, it is 0. Now, going to our subnet mask. This is a subnet mask. The first subnet mask we use, which is the popular subnet mask, anytime you use ipconfig, even your pocket MiFi is the most subnet mask they use is 255.255.255.0. The reason why they're using this is because it can take more devices on a network. A 255.255.255.0 subnet mask can take 254 devices on a single network. Just a single network. Do you understand? That is why it is most commonly used. Do you get now? So
Yeah,
now we want to create another subnet mask different from the popular subnet mask, which is the 255.255.0. The first one we did the 255.255.0, the common one. So to calculate this now, this 255, if you add all these numbers together, you get 255. You understand? That means everything will be what? Will be 1, right? That is why we have 8 ones. Same thing here, 8 ones. Same thing here, 8 ones. And when this one was 0, we had all zeros. Now, if you calculate all the ones, you have 8 ones here, 8 ones here, 8 ones here. 8 times 3 will give you 24.
24. Okay.
Are you getting me? That is how they got a CIDR notation of 24.
Okay.
Now, for you to now know how many devices can be on that network, you will do 2 raised to power the number of zeros you have left. Now, you know when it was 255.255.255.0, we had 8 zeros left. So by the time we did 2 raised to the power of 8, we got 256. Now, if you subtract 2, you get 254, which means you can have 254 devices on a single subnetted network. Do you understand that? Now, we want to create a CIDR of /27. Now, for us to do that, we just make sure our ones are 27, right? Now, for us to make sure our ones are 27, we have 24. Yeah? We want to create a subnet mask of a CIDR notation of /27. And for us to do that, we make sure our ones, we had 24 ones before, so we had 3 more 27. And for us to get this one to 224, you know, we have 1 1, 3 ones, and 5 zeros. Now, if you go back here and you put 3 ones here and you put 5 zeros here, by the time you add the ones that have your ones, you get 224. That means the subnet mask is 255.255.255.224. That is our subnet mask for a CIDR notation of 27. How did we get 27? If we calculate all the ones that we have 24 in 8 in 3 places, then plus 3, we have 27. Now, for us to know, this CIDR notation that we're trying to create, how many devices could actually be on a network, we now do 2 raised to the power of the number of zeros we have left, which gave us 2 raised to the power of 5. We have 32. Then minus 2, we have 30, which means we can only have 30 devices on that network. And I said the reason why we are removing 2 is, number 1, we have to remove our network address, which is 192.168.1.0. You cannot assign this to any device. You understand? And the last one, which is our broadcast address, which is the last IP address on that network. The reason why it is 31, because if you say 0 to 31, you will get 32. Do you understand? You might be thinking, why is it not 32? You know, our calculation says we can have 32, and we are starting from 0. Do you understand? So 0 to 31 is already 32. And now, according to the calculation, we are removing 2 IPs, which is, number 1, our network IP address, and number 2, our broadcast IP address. Do you understand? So that means the number of IP addresses we can assign, sorry, this is supposed to be 30. The number of IP addresses we can assign is 1 all the way to, so that means you can assign 192.168.1, let me do it like this. So we can assign 192.168.1. We can assign 192.168.2. We can assign 192.168.3 all the way to 30. The moment you are now getting to 192.168.2, you are no longer on this network. You are now on a different subnetted network. You understand that? The moment you now have this, which is 192.168, this one is all the way to, because what you just do here is 30. Sorry, what am I doing here, sir? So you do one, you have 1 here plus 32. That means we have 33 here. Sorry, that was a mistake. 33 here. If you have 30 plus 32, that means you have 62 here. So that means all the way from 192.168.2.33, you can have it all the way to 62. That is also 30 devices on that network. And the broadcast address for this network will now be, so the BA will now be 192.168.1.63. So the BA for this one, the BA for this is 192.168.1.31, right? You understand now?
Yeah,
Another person
I
is
would
doing-
also watch. I'll watch the videos to understand better. Thank you.
All right. Another person is asking question. You guys will stay here till 10, because I have to finish this. So I will continue next class. Madu, quickly ask your question so we can continue.
Yeah, good evening.
Good evening.
I want to ask, this 2 raised to the power of 5, is it a fixed number?
It is not a fixed number. It has to do with the number of zeros we have left in our subnet mask when we do our calculation. You understand? For instance, now if we want to create, let's assume we want to create a subnet mask of let's say, okay, let's turn this one to, let's even make it only single one.
Sorry,
Let's assume we want to do it like this.
what I'm asking.
Can you listen? I said it is not a fixed number, the 2 raised to the power 5. It has to do with, as a network engineer, okay, you want to design a network for an organization. How many devices do you want to be on a particular network? You understand? It is when you know the number of devices you want the organization to have on a particular network, that is when you determine the kind of subnet mask calculation that you will do. For us now, we are doing a subnet mask of /27 because we want, in that organization, let's say we want to build a network topology for an organization. In that organization, we want them to have, in a single department, we want them to only be able to connect 30 devices in that department. That is why we are using a subnet mask of. So let's use this one now that I just did now. So what do we have here now? 1, 1, 1, 1. We have 24, then we have 25, right? So what will 25 give us? What do we have left? We have 7 zeros left. So 2 raised to the power of 7. What will 2 raised to the power of 7 give us? Anybody?
See, my question is, I'm not talking about the number that 2 is raised to. I'm asking that 2, because I noticed you use it to
Yeah, the reason why, okay, you are saying if this 2 is it
fixed?
Yeah, it is fixed because it is binary. Binary means 2. So the reason why it is 2 is because you have 1s and 0s. Those are only 2 digits that your computer communicates with. Do you understand? So it is fixed. Okay. Yeah, I get you now. The 2 is fixed because it is binary. Binary means 2, which is 1s and 0s. Do you understand?
Yeah, thank you. And then I want to ask another question. I had mentioned a hacker can determine, with the subnet mask, a hacker can determine number of devices that can be assigned to an IP address. So my question is, can an hacker see the total number of devices that are connected to a particular IP address at a particular time?
Now, for an hacker to hack into your network, first, if he is not getting help from inside, he needs your public IP. Now, once an hacker gets access to your public IP and hacks into your network, it has to assign itself a private IP for it to be able to move around your network without being suspicious. Do you understand? You know, private IP is for communication within a network, while public IP is for communication outside your network. So an hacker hacks into your device with your public IP. Now, after hacking into your device, let's assume an hacker hacks into your network now and does IP config. Now, immediately the hacker does IP config, he sees this subnet mask. As somebody that knows networking, you already understand that, okay, that means on a particular network, they have 254 devices. This is also an IP that is assigned to a particular device. Now, it's now left to the hacker to know which of the IPs is going to assign to itself for it to do what we call lateral movements. Lateral movement is a kind of movement whereby you don't really easily suspect that somebody is moving around because you feel the person is amongst your network. Do you understand? So an hacker cannot easily see your private IP topology except you post it online or hacks into your network using the public IP of that network that the network is using to communicate over the internet, because the router that has the public IP also has its own private IP. So immediately an hacker hacks into a router, the hacker can also use the private IP of that hacker of the router to also communicate within that network. Do you understand?
Yeah, I understand.
All right.
Thank you.
So please, let's just continue. I hope you guys can wait till we are through with this, because I want to finish this in this class so that we can move ahead. So now let's go to our packet tracer. So now this is our packet tracer. So let me just do some simple explanations here. Now, if you look down here, you have network devices. Network devices, if you click on it, it gives you routers. These are routers. Then if you click on this is switches. Do you understand? These are hubs. Then this is a wireless connection. This is a firewall that has security. Then this is a WAN, which is a wide area network. If you click on this, you have access to devices. So you have endpoint devices. You have a PC, laptop, server, phone, all that. You have homes if you want to choose home. You also have smart city. You have Bluetooth and all the rest. So if you click on this one, you have your cables. These are your cables here. The one we'll be making use of is this copper straight through. This is what we'll be making use of. Now for this one, you have miscellaneous. Then you have this. Now, if you come up here, let me carry a device first. Okay, let me carry a router. I'll just hold down and carry. Let me carry a router. Let me go to a device. Let me carry a PC, carry a laptop, carry a PC, carry another laptop. So now, what some of these things are here now? For this one now, this one is to place a note. If I click on this now, that means I want to place a note somewhere. That is what this note is all about. If I click on this one, I want to do probably I want to select outline. That is, okay, let me change the color. Let me fill color. I fill the color to this. That means anything I draw will give me that color. So you can use Ctrl Z, or you can click Now this one is to click outside this particular place to click outside. So if I click on this thing, I can decide to delete it, or I can drag through and delete. I can delete it. I can just draw through this place too. Click outside, draw through this place, delete. Click on delete. That is what that is for. Then real times, this simulation, your real times, anything you are doing here, you want it to be real, just like the way a real-time simulation will be like. But if you choose simulation, that is, you want it to move according to how you want it to. So when you press play, it moves according to how you want it to move. That is what that is all about. So those just the major things. So now what we want to do now, we want to create a simple network. Then we also create a segmented network. So now let's use two PCs and two laptops. So in an organization, let's assume, okay, this is a router. We need a switch. Let us use a switch. So I go to switch, carry this. So I need two switches, carry this. Let's create two different networks. So two laptops, two switches, and one router, right? So now this is where your subnet max calculation comes in. So now if I go back to my calculation now, we want to use a so we want to use this calculation now, whereby we have a CIDR notation of 27. That is, we only have 30 devices per network. But inside that 30 devices per network, we are just going to assign 4 devices. We don't have time to be assigning up to 30. So let's start with connecting our devices. So let's go to our cable. So you click on your cable. You click on the first device. Let's use Fastnet. You connect to your switch. So let's use Fast Ethernet 1. You click on your cable again, your laptop. Sorry, let's start from the top. Let's start from this first one. So this one, you are connecting to your Fast Ethernet 0 to your switch, Fast Ethernet 1. This one that is what is left there. From laptop, connect this, Fast Ethernet 0. From this, we connect this, connect it to Fast Ethernet this. All right. So from this, we connect. Let us connect let's connect our switch to our switch. I'm using Giga Ethernet ports, so Giga Ethernet. So the same thing, we connect this. Sorry. Same thing, we connect this with this. Fast Ethernet 1. Same thing, we connect this with this. This. Connect this to this. All right. Let's connect the routers. So I connect this. I use Giga Ethernet to this as our router. I connect this to this. So now we have done our connections. Let's arrange it well. Arrange it well. All right. So now I want to do a manual assigning of IPs, which is a manual configuration for our organization now. So let's go into this PC. Now, if you come into this PC, you just click on it, then you go to desktop. When you go to desktop, then you go to terminal. Sorry, not terminal. That is. You go to IP configuration. So on your system too, if you search for IP configuration, you see something like that. So this is just like a simulation of a real life development of a network. So I'll go to IP configuration. Now the IP address we want to assign to this. So we are using the first network, right? So that means we can assign from this IP address. So let's do now. Listen to, there's another thing. You know, I said we do -2, right? That means we have 2 IP address left. Now, also, you also have to leave out another IP address for something we call a gateway communication. So now you can decide any IP address you want to use. For most network engineers, they use the first IP address that is assignable, which is 192.168.1.1, so that they will easily remember. Because if you check this place now, you notice there's something we call, there's a gateway here. Can you see that even this one uses .1, the first network on that device? You could decide to use anyone, you understand? But to make sure, you just make sure you remember. So most time they use the first one. So that means now the first one is out. Do you understand? So we can start assigning from 192.168.this. All right. So let us assign. So IP address, we assign 192.168. So 192.168.1.2, that's what we assign to the first. So the subnet max, you see that the automatic subnet max is 255.255.0, which is a CIDR of /24, but that is not the one we are using. We are using /27, which is 224, right? So I'll change this to 224. Change this to 224. Then our gateway, we say we are using the first network. That's what we agreed, right? So 192.168.1.1, right? So we cancel. So if you look at it, if you just over it now, you see that we have assigned, you see automatically it already put a /27. You know, we did not do the calculation here, but automatically it understands that subnet max that we are using is a /27. Do you get that? So we go to this one. So we want to assign on the same network. So this one, we can jump. We can say 192.168.1.15 is still on that, is still within that network, right? Until we get to 30 before we are outside that network. Our subnet max 224 gateway .1.1, right? We cancel, so we give that one 15. So we'll give this one 215. Let's see, what do we give this to IP config? 192.168.2. Let's say we give this one 20. Let's give this one 20. Subnet max 224. Our gateway 1.1. Cancel the last device. We give this. Let's give this 25. If this gives 25, or can even give it 30. And give it 30. And let's just say 25. Let's stay at 25. So we don't go outside. Then this 2. Now this subnet max is telling us is letting the systems you are configuring know that this is the network subnet calculation for this. So our gateway, we are using .1.1, right? So that's this. Now this, we've configured a network here. Let's give it a color so that it would be different. So let's give it into this. Let's select color. Okay, so let's give it this. Now let's name this now. So the network address for this network we created here now is 192.168.1.1.0/27. That is the name of this network. That is the network address. So let's start with this PC also. So let's do something. Let's use just one. Let's use just one switch. Okay, no, let's leave it as 2. Let's leave it as 2. So for this network now, we are on another network. Let's go here. So we are through with this first network. We've already used this network. Let's go to another network. For this one, 192.168.2.0/27, that's the name of this network. So for this device now, we give it 192.1.2 because we are leaving 192. We are leaving .1 dot sorry, I'm taking your time. 2.2 because we are leaving, so our subnet max is 224. Our gateway now, for the first one, our gateway was this. Now for this other network, our gateway will be this because this is the first IP. So let's use this particular IP for our gateway, but that is what we are deciding to use for that network. Sorry, there's a mistake somewhere. So this is still .1. Sorry, the network address for this is going to be .1. Sorry, we've not gotten to 2. .1 dot .1.33 .1.32. Sorry, .1.32/27. So the first IP is 192.168.1. We are still a long way to get to 2. Before we can get to 2, that means we have already maximized this and we've gotten to 255 before we jump to 2. Hope you understand that and you don't get confused. So this is .1.62. All right, so this is it. So this one stopped at 31. So the second one will be the network address, which is starting at 32. You get that right? So that means the network address for this is 1. Let's start from 34. So our gateway is .1.33. That is the first IP on that network. Invalid gateway address. This is invalid gateway address.
You mean 35, right?
Why is it telling us? Globally gateway address. Maybe 35. Maybe 35. Okay. For this one, let's give it dot one dot. I think if we jump to 40, we are seeing that network 40 subnet max 224. So our gateway .1.33. What's wrong with this now? Why is it valid gateway address? Oh, we assigned that. Yeah.
Sorry, why are we going to .1 back? I thought we were using .2 initially.
Yeah, it was a mistake. The .2, we can use the .2, but we've not gotten. It's not the second network. It's like we jumped. It's not the second network because for us to get to 2, that means we have maximized this 35 all the way to 255 before you now move to 2. You understand?
Okay.
All right. So we have segmented 2 different networks. Let's give this one. Let's give it All right. All right, so let's label the network address here. So the network address here is 192.168.1.32 /27, right? So if we hover over this one now, we hover over this place, you see that it has given it a CIDR notation. So now let us know if we have actually created a network. Now let me try something. The network address for this one is 192.168.1.15, right? So from here now, let us ping 192.168.1.15. So if you go to your terminal, what's this now? So you go to your command prompt. So ping 192.168.1.15, right? I think it's 15. Let's see if it will respond. Okay, our stuff is on simulation. Can you see it's on simulation? So that means I have to go and press play before it works. So let's put it on real time. On real time, can you see it has responded? Now, this response we are getting is what they call the ICMP request. Do you understand? It is a request for troubleshooting a network to show you that a network is actually responsive or not. Can you see that this PC2 actually responded to us when we tried to ping it? So let's check for this one. What is this IP address? 192.168.25, right? So let's try to ping 192.168.25. Can you see it also responded, right? To show you that we are on the same, that they are on the same network due to our calculation. Now let's not try this now. This is 192.168.1.35. Let's try to ping it. That's 1.35, right? Can you see it is not responding? This is to show you that it is telling you that it is not on the same network. You get that now? That is the essence of your calculation. To tell you that it is not on the same network. That's why it is not responding. Do you get that now? So, but if this one now, look at this now, this is 192.168.1.36. Let's try to ping it from here. So command prompt 192.168.1.36. Sorry, ping. Not ping. Sorry, I'm taking your time. Can you see it is responded, which means our network is responding to show you that these ones are on the same network. Now, let me show you what a broadcast address does. Broadcast address is just like saying, how will I put it? It's broadcast to everybody. It doesn't keep secret. So for this network now, we said our broadcast address is what? The last network on that device, which is 192.168.1.31. So let us try to ping this. You would realize what would happen. So let's ping it from here now. We are on this network, right? That's 1.31. Now notice what happens. Now can you see that it pinged the first PC, pinged the second one, pinged the third one? Can you see that it is pinging all the PCs on that device? The only one it is not going to ping, it is the particular PC that we are pinging from. You understand? That is the essence of a broadcast address, because a broadcast address just communicates to all the IPs on that device to show that, to see the ones that are not responsive. So if a network engineer tries to ping the broadcast address of that network, anyone that does not respond, then they will know there's an issue with that particular device. If you can see here now, it's pinged all the remaining 3 devices. This .15, .25, we have .20. Can you see? And a ping request actually goes 4 times. You understand? It goes 4 times. But if you are doing it on Kali, it goes non-stop, except you add some commands to it. Do you get that now? So let us now do something. So now we created a simple network now. So now another thing we can do is we can actually make this network communicate with this. We can make this network here communicate with this network. That is where our broadcast address comes in. Do you understand? So for us to now configure that, we'll go into our switch, first switch and second switch. If you go into our first switch, we can decide to use the command, we can decide to use command line, you can decide to use normal physical configuration. This is just to show you the normal configuration. So let's first understand what we are doing. So if I hover over this place now, if you hover over this place now, you will see gig, you see gig 0000, right? That's giga internet 00. That's the port we connected it to. That's the port we connected. If you hover over this place too, you'll see gig 0001. That is the port we connected it to. So now we enter into our router. When we enter into our router, you can decide to use the command line. You can decide to use command line or use the configuration, the manual configuration. Now, we need to understand the interface that we want to access. The interface we want to access here now is the gig 00, right? That is the interface we want to access. Now we'll go into this router because our router is the one that is serving as bridge between those networks now. So we want to access gig internet 0, right? You understand? So for us to first do this, we need to turn off our device. Now to turn off our device, we come here, we turn it off, then we'll go to config. Sorry, we leave it on. I said turn it off. We turn it, is it on now? Okay, it is on. It's on now. So we'll go to config. Device is still good to know. Sorry for turning it off. So device is on. So we want to access this interface, gig Ethernet. So we'll go into this place. When we go into this place, we will set our IP address. Now the IP address now we are going to set is the gateway IP of this first network. And you remember our gateway, we said it should be 192.168.1.1, right? Now, if you look at the command line here, you see this is the command you will use if you are using the CLI. You just type enable config T, then interface giga internet. Probably we'll try it for the next one. So this is just what you need to do here. Then you press on, you put on the status. The status here means if you look at the command, it means no shutdown. No shutdown. That is the status we'll put on there. Then our subnet mask, sorry, we have to change it, is 224. Let's shut down and shut it on again. So our subnet max is 224. We'll close that. Now you realize if you see this orange, it means it's trying to connect. You know, before it was just purely red. So let us access this other side. So you know this one is giga ethernet 00.1. So we enter our router again. So this is the interface. This is the interface here. So now the IP address we will not be putting here. Okay, I said we will use the CLI, right? Let's try the CLI. I hope I remember the commands. Let's just see if I remember the commands. So now let me first exit. It. So normally, if you're coming in to the CLI, your command is enable. The first thing is enable. After enable, then use config T. Then config T. After config T, now the interface we want to access. You know, the interface is G000/1, right? So we now say interface G0/0/0/0/0/0/1, right? That is the interface we want to enter into. We press enter. Now we are into that interface. Then we'll do whatever we want to do here. So you use IP address, our gateway for the second one, which is 192.168.1. I think 33, right? Then space your subnet max, which is 255.255.255.224, right? Then press enter. Then the next command will now be no short. We want communication between there. We press enter. So now let's check. You see that it is trying to connect, right? It's trying to connect. Let it finish connecting. Then we try it again. Now this is what we call network segmentation. Do you understand? Because you can just build a simple network whereby you just have the /24. Okay, you want all the 254 devices or 253 devices to be on one network. Fine. You just need one router and a switch. You might not even need a router if it's just within communication. You just need one router or one switch. Then you give all the devices your IP addresses. So far you're on that same network, due to your calculation, it will be able to communicate freely. Do you understand? But when you want to segment, you have to calculate the networks separately. You get it now? So if we calculate network separately, now let's try what we tried the other time. This is 192.168.1.35. You know, when we tried to ping it from here the other time, it did not work. So let us try it again and see if it would work. That's 35, right? So can you see it is now pinging? That means it can now communicate with that particular network. Do you understand? So what is the essence of segmenting a network? For instance, now if an hacker should gain access into this first network, what a network security person will do will just enter into the router and shut down this other network so that the hacker will not be able to crawl into the second network. Do you understand? That is one of the essence of segmentation in network security. You get that now? So this is a simple network topology. Do you understand that? So let me show you what I want to quickly show you here. You know, we're talking about packets. So let me show you a sample of packets. Let's use simulation mode. So now let's assume, you know, we segmented this network now. So now let's assume I want to send message from computer 1, from PC1 to PC2 on the second network, right? Let's assume this department now. Let's say this is, I know you. Let's say this is admin, or let's say this is customer care. Let's say this customer care department, and this is what should we name this? Accounting or admin. It is admin deputy. So now let's assume I want to send message from, let's say, the owner of this PC now. Whose name should we use? Let's check. Whose name should we use? Let's use Bukumi and Olisa, okay. Let's say this is Olisa working in customer care. Now this is Bukumi's PC here. Now this is Bukumi's PC here. So now let me say I want to send a message from Olisa to Bukumi. So now let me press play now and see what happens. Now play. Can you see the way the packet, this message that is going now is known as the packet. Now it goes to the switch, the first switch, it goes to the router, right? Now from the router, it looks for the Bukumi I'm trying to send message to. Now when you see that it sends message to almost everyone, but it cancels out the others. Only Bukumi will get my message. Can you see the other people that does not need the message? It cancelled everybody out. Only Bukumi got the message. That is one usefulness of a switch. But if it were to be an hub will send message to everybody. If it's Bukumi you're sending message to, everybody gets the message that is Bukumi you're sending message to. You understand? That is the difference between switch and hub. And also the fact that the network is segmented. So if I shut down this part now, let's shut down this part. Let me shut down. So we go to let's use the so let's shut it down. Media internet one, we shut it down now. Let's shut it down. So can you see we have shut this place down now? So let's assume an hacker got access into this network where all inside this customer department now. You know, I've actually shut down the admin department. So that means the hacker cannot actually go into that network. For you to know the hacker cannot go into that network, let's do something. I'll use a message now. The same Olisa to Bukumi now. Let's press play. Now you see that the message will not pass through. The message will not go through. Or the packets, let's be professional. The packets will not go through. Can you see it's coming back? You understand? Now, the moment I sent the packet first, it did the first handshake, which is who owns this IP. It first looks for the IP address of this person I'm sending this message. Okay, he said I send it to Bukumi. What is Bukumi's PC's IP? It first looks for it. Do you understand? Then Bukumi, once it gets Bukumi now respond. This is my IP address. Let us connect before the message is now sent. That is the TCP three-way handshake. If I click on this now, you would be able to understand some part of the layers. I think some of the layers, these are the OSI model. Can you see the OSI model, the way your message is going through? But because I have shut down that place, the message is not going through. So let me use this person, from Olisa to this person. Let's send the message. No, pause. Stop. Olisa to this person. Play. So now I'm sending message to this person now. And see when it gets to this laptop, it marks. Let's do this first. Yeah, let's send again. Okay. So this is the difference between simulation mode and real time. Simulation, you get to decide how you want it to be moving. If it is real time, it goes without you even know how it went through. That is what you actually experience in real life, because you don't know how your packets are moving. You just know when you send a WhatsApp message to somebody, the person gets it. You don't know what is happening behind the scenes. So for you to see what is happening behind the scenes, so can you see my message went from Olisa to this laptop here? That is the first handshake. Then it's now responded back. Okay, I've gotten that person's IP. Let us now connect. Then it connects. It's now responded back to say I have sent your message. So let us check the TCP here now. Let us check the layers, the different layers. So this is the OSI model. Can you see in layer 1? I think he explained to you that layer 1 is your cable connection. Layer 1 went through. Layer 2 also went through. Then let's go to the last one. No, not this. So can you see this is where layer 3? Can you see where the source IP, the IP is looking for the IP address of the second PC? You understand? So this is just a sample of what the OSI model or the OC model looks like.